So we pick up this second section of Chapter 15 with objective number 4, looking at what we call immunoglobulins, also a lot of times abbreviated capital I lowercase g. So these are molecules. They have 4 polypeptide chains connected to disulfide bonds, so that's what chemically makes them up. And so all antibodies have 2 functionally distinct fragments. So they have what's called the antigen binding fragment, known as the Fabs. They also have a crystallizable fragment, known as FC, that actually binds to cells and molecules of our immune system. And so if you look at the typical antibody structure, that's what we see, right? So we see the antigen binding areas that's here, that's the Fab, and then you see the crystallized part that's here, that's the FC. And so all of this together makes up an antibody that hopefully an antigen would bind to, or the epitope of that antigen would bind to, and trigger an immune response. So you can kind of see some various models of this that's found in your textbook. So again, the whole idea here is that the antigen binds to the antibody in that Fab site, right? We do recall that these are very specific, right? So the Fab sites, where those antigens fits in, are specific to a certain antigen. It's all about shape, right? So if it's wrong shape, it doesn't fit, it doesn't trigger an immune response. So shape is very, very important when we talk about those. And you can kind of see some pictures of wrong shape, kind of a shape versus perfect shape. So we have 5 classes of immunoglobulins, okay, basically 5 classes of antibodies. And so we have IgG, IgA, IgM, IgD, and IgE. So really quickly, just to note a couple of differences. So IgG, this one is considered to be the most prevalent immunoglobulin, or the most prevalent antibody that we see in our bodies. And so it's produced by plasma cells, and it's memory cells. So it serves a purpose of maintaining that memory for future reference. We also see IgA. So this is one that's heavily in circulation through your blood. And it's responsible for mucus and serous secretions. So when it is triggered, when the epitope or the antigen binds to it, it's going to trigger fluid secretions. IgM, so this one is the first class that's actually synthesized that follows an actual encounter with an antigen. IgD, so this one serves as a receptor for antigens on B cells, so heavily associated with B cells. And then IgE is the one that's involved in allergic responses and parasitic worm infections. And so we'll come back to IgE in the next chapter. So you can kind of see the differences in those as they talk through it. They also mention the difference between the primary and the secondary response. And so the biggest thing to note here is the primary response. Obviously, this is the latent period where no measurable antibody occurs early on. So this is like first exposure to an antigen, and so we typically don't see a whole lot that goes on with this one, right? But the secondary response happens a little bit later on. And so it mentions this is a latent period's lacking here, so it happens a lot quicker because we have memory lymphocytes from the earlier response, from the primary response. They're immediately ready to react. So what that tells us then, again, is specific immunity. It's based on exposure, right? So the first time that you encounter it, you don't trigger a quick response because you've never seen it before. You don't necessarily know right off the bat that it's bad, and even though you do find out that it's bad, it's hard to combat it because you've never seen it before. But a secondary response says, okay, we've already seen this thing, we know what this thing looks like, we know what this thing does, and so we quickly recognize it, and then we quickly attack it. And so what boosters do, this is secondary response, is also called the anamnestic response. Same term, same definition. Boosters, you have to get booster shots. So what they do is they provide a quick, potent strike against exposure to infectious agents. So a booster just kind of reminds your body of, hey, this is what this looks like in case you encounter it. Okay. So a couple of categories of immunity that we want to briefly mention, and again, you talk through these in Anatomy 2. We're going to hit on these quickly. So you have active versus passive immunity, and so these terms describe the length of time you're going to have that immunity, right? So an active immunity, it creates a memory. It's going to take time, but it's also going to be long lasting. So active immunity is something that you could have for years and years and years down the road. Passive immunity, it does not create a memory. It acts immediately, and it's very short term. Natural versus artificial describes how you actually acquired that immunity. So natural immunity just says that you have acquired it as a part of normal life experiences. So you caught an infection and you now have built up a natural immunity to it. Artificial immunity is that's acquired through a medical procedure such as a vaccine. So if we put these words together, we get some different origins of immunity. So for example, natural, active. Okay, so natural means you're going to get this from an infection, but the active means that memory is going to stay with you for an extended period of time. So after you recover from that disease, you are actively resistant to being reinfected by that particular type of infection. Natural passive, again, so you naturally acquired this. This a lot of time is from mother to child, right? But it's passive, so it's not going to stay long lasting. Great example of this is from the mother's milk, right? So initially through breastfeeding, the mother naturally passes on some antibodies to the child, but they're not going to stay with that child forever. Eventually the child's going to have to develop their own immune system to fight off infection, but for those first couple of days, first couple of weeks, this immunity stays with them to protect them until they develop their own. You also have artificial, right? So artificial active versus artificial passive. So artificial active, these are vaccinations that trigger antibodies. They trigger memory. They're going to stay with you for an extended period of time. Artificial passive, these are going to be administered to the patient. They target specific antibodies. They deal with the issue right there, but then it does not stay with you for extended periods of time. A couple of vocabulary words: immunotherapy. This is passive immunization in which a person is given antibodies for a short period of time. You also have immunization. This is the active form of it. So we're looking to form memories so that you are protected for an extended period of time. As far as vaccines are concerned, so we do look at how vaccines are prepared. So they kind of give you a quick checklist of requirements for an effective vaccine. So low level of adverse side effects, right? If you get a flu shot, it tells you that you will see some side effects. You may see a mild fever, that type of thing, but it shouldn't cause serious harm, right? It should protect you against exposure to the pathogen. It should stimulate an antibody response, right? It should have long-term lasting effects. We want them to be active, right? Minimal dosage and boosters should be inexpensive, right? So for vaccine antigens that we see, so vaccines that are administered today fall into one of these four categories. So we see the killed whole cells or inactivated viruses. This is what polio is. We see live attenuated cells or viruses. This is what the TB is. They're actually giving you live cells. Antigenic molecules derived from bacterial cells or viruses. So anthrax is this, the one that treats hepatitis A is this. We're also seeing, though, genetically engineered microbes or microbial agents being administered in vaccine form. So they go into a little bit of detail as to attenuated versus killed. Right? So the advantage of an attenuated, advantage of giving live preparations of vaccines is that the organisms can multiply, right? So they can produce an infection but not a disease like the natural organism, and so it's more long-lasting protection, shows your body exactly what's supposed to happen there, and it usually requires fewer dosages. The disadvantage, though, is these live preparations, they require special storage. They could also be transmitted to other people that have not had prior exposure, right? And there's, again, the potential they could mutate and cause a whole different type of infection. Right, so they go through some different strategies in vaccine design. So some exact antigenic determinants that can be used. So they mentioned that sometimes they use capsules, surface proteins, exotoxins to deal with fighting off infections. Definitely something that they mentioned there. And then they just, again, to give you some strategies in the design of the difference in a whole cell versus vaccines from parts, and then even recombinant vaccines as well. Interesting thing that they have done is they actually have developed and are using what's called a Trojan horse vaccine. So if you remember the story of the Trojan horse back in the day, they basically inserted warriors in a horse, right, a big horse, and then took that to a different area. They did not know that the villagers were in it, and so they were able to come out at night and actually attack the city, right? So the idea here is in a Trojan horse vaccine is you have genetic material from a pathogen inserted into a live carrier non-pathogen, and in turn this actually can harm or even kill that type of virus or bacterial infection. So interesting stuff that they've got going on with genetically engineered vaccines and that type of stuff. And then they kind of give you some different tables you can look at with some different disease vaccines, some of the names that you may have heard of, and actually what they attack with those. And you can look through those in a little more detail if you'd like. As far as the routes of administration, side effects of vaccines, so most vaccines are administered through injection, although we do know that there are a couple that there's like a nasal spray that you can do, that type of stuff, but most of them are going to be the injection. Some vaccines require an adjuvant, which is a compound that enhances and prolongs the retention of the antigen. Again, that's kind of a rare thing. You don't see it with a lot of them. Most, right now there's a big push for like anti-vaccines. Like a lot of people don't like them. But what we actually know scientifically is there are more benefits to them than there are risks. So we know that there's side effects, right? We know that you could have a local reaction to the injection site, could cause a fever, could cause an allergic response, maybe even some potential neurological effects. But again, we scientifically believe that there's more benefit to it than there actually is risk. Last thing they mention in the chapter is something called herd immunity. So herd immunity, if you think about herd, like this would be like a group, okay, of organisms. And so in herd immunity, immune individuals will not harbor it, reducing the occurrence of pathogens. So you think about if you've got a bunch of humans in an area, and half of those have built up an immunity, right? So half of those have built up immunity to a certain type of infection. So then you're not going to have an occurrence of that pathogen because their bodies are going to be able to fight it off very quickly, right? So then what they say based on herd immunity is then that you're less likely that a non-immunized person would encounter the pathogen because you've got all those immune individuals in the area that are basically killing off those microbes before they actually become pathogenic. And so herd immunity is something that we actually have tried a lot, or actually still trying with vaccinations, is the more people we can get vaccinated, right, in an area, then potentially those that are not vaccinated would not be in danger because those that are vaccinated would basically be dealing with the problem. So that's what herd immunity actually is.